everybody, welcome to your section 9.1 and 9.2 review of quadratic notes. Go ahead and print this, and if you don't have a printer, go ahead and copy it down. Make sure you give yourself a nice graph for each one. Same with your homework if you have to do it by hand. This is the only one where we're actually doing some graphing. So let's get started. So problems number 1 through 4, it says graph each quadratic function and answer the given questions. Use the parent function. So let's have a moment where we talk about parent function again. So we have our piece of patty paper. We learn that the parent function is y equals x squared. That's the basic form of that parent function. And the graph of that was a point at 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. That pattern being at the 0, and then go over 1, up 1, and some kids like to think of it as go over 1, up 3. You can also think of it as starting from the original and going over 2, up 4. It's up to you. So here's my basic parent function. Again, 0, 0, 1, 1, 1, 3, 1, 1, 1, 3. And then we can move this around and graph with it. So we can see on this first one that here's the parent function right here. F of x equals x squared, y equals x squared. There's our parent function. But it wants us to move it down 1. So we're going to take our parent function and we're going to move it down once. And now we're going to draw that underneath. So I know I move down my vertex here. 1, 1, 1, 3, 1, 1, 1, 3. And again, this is review. We took a test on this prior to our closure. So you can always go back to those notes. So there's our beautiful graph. Let's answer the questions that go with it. Vertex. Vertex is the point that's either the lowest point of the parabola or the highest point. In this case, it's 0, negative 1. 0, negative 1 are zeros. Zeros are where it crosses that x-axis. It's those 2 points. So that's going to be negative 1 and 1, or you could say negative 1, 0, and 1, 0. Now, thinking back to our function smushing machine, if I had, that was that PowerPoint that I showed you guys. Domain is another word for x values. So domain is x, range is y. Get it wrong, I'll poke you in the eye. Again, domain is x, range is y. Get it wrong, I'll poke you in the eye. So imagine, here's my x. We can all agree that that is my x-axis. If I opened up my x-axis and I smash this shape in between 2 lines that were trying to smash it, it would flatten out and it would cover every single point here. So my domain is going to be all real numbers. We watched that PowerPoint a few times in class. The range is my y guy. It's what would this look like if I smash this shape up against the y-axis? Well, it would be a line from here upwards, so it would be all my y values that are greater than or equal to negative 1. Now this part's a little bit more sassy. So we can see if I rode a skateboard and I stood right here on the tip, the first thing that would be happening is I would be going down, down, down on my skateboard. I would go to the bottom of the bowl of the skateboard park there. And then I would go back up, 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 and I would be increasing on the other side. So if I'm on my skateboard, this side I'm decreasing when I'm going down, and this side I'm increasing if I was to go to the skate park and go into the bowl. So we know that negative infinity is on this side. We know that positive infinity is on this side. And we want to know the intervals of increase. Well, intervals of increase are from here up. So we want to know our x values, our intervals of increase. So that's going to be x value, if we go straight up, that's 0 all the way to positive infinity. From 0 to positive infinity. Decrease is this side. That's going to be negative infinity to 0. Whoops. Negative infinity to 0. Okay. So there's our question number 1. Great. I'm going to do another video for question number 2.